now we're skipping ahead to chapter 5. It fits better this way because chapter 5 talks about the binomial and the multinomial theorems. So here's a quick review of Pascal's triangle. We've taught it before a little bit, but I'll remind you how you make it. Start with 1 on the row 0. That's the very top row. Then you put 1, 1 for the first row underneath that. And then you skip, as you write the numbers, you always leave a blank space directly below the number above and fill in between the two numbers above. And when you fill in, you add the two numbers above. So 1 plus 1 equals 2. And for the third row, 1 plus 2 equals 3, 2 plus 1 equals 3. So you notice that it will always be palindromic. It'll always first increase and then decrease. And it'll decrease with exactly the same steps as it increased in reverse order. Another thing to notice is what happens if you add up the numbers on each row. There's the row sums on the right. 1, 2, 2 plus 1 plus 1 is 4. 3 plus 3 plus 1 plus 1 is 8. They are looking like exactly doubling every time. One of the first ways that people use the Pascal's triangle is to find the coefficients for a binomial to a power expanded. For instance, x plus y to the 4. If you expand that and collect all the like terms, you get the answer that's there. 1 times x to the 4, 4x cubed y, 6x squared y squared, 4xy cubed, plus 1y to the 4. And those coefficients are the fourth row, the n equals 4 row of Pascal's triangle. 1, 4, 6, 4, 1. So that's very handy. Row 4 is also the combinations. 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Combinations are numbers of subsets of the set 1, 2, 3, 4 of any given size. So it's the subsets of size 0, which there's only one of those, the empty set. Then the subsets of size 1, there's 4 of those. The subsets of size 2, there's 6 of those. And then the subsets of size 3, which you can tell is going to be the same as the subsets of size 1, because if you pick 1, it's the same as picking 3 not to have. So there's a symmetry there. To see that these give you the coefficients that are correct, we should work out that x plus y to the 4 a little bit. So x plus y to the 4 is x plus y 4 times, all multiplied together, and then expand it. And we could ask the question for any of those like terms. But for instance, how many ways can we make the term x cubed y? Because it won't just happen once, it'll happen for any 3 of the 4 x plus y's in that product. So you pick the first 3, you get x, x, x. You pick 3 to contribute an x, and choose the other one to contribute the y. Because when you multiply out a series of parenthetical expressions, you have to multiply everything in each of them by every other possible term because of the distributive rules. So there are 4 choose 3 ways to get x cubed y. So if you expand it out entirely and count them up, there will be 4 of them. That's why you have the coefficient 4. So in general, the nth row of Pascal's triangle is going to be n choose 0, n choose 1, all the way up to n choose n. It's going to sum to 2 to the n, which makes sense because each of those numbers, one at a time, are counting the subsets of a given size. So when you count up all the subsets together, that's the size of the power set, which we already found out was 2 to the n by going down the set and deciding for each element, 1 through n, whether to keep it or not. 2 choices each, so 2 to the n. It always starts with 1 and ends with 1 each row. The second number in each row is always going to be n, because it's n choose 1. And n choose k is always going to be the sum of the 2 entries in the previous row. So that would be n minus 1 choose k plus n minus 1 choose k plus 1. And then here's the binomial theorem. If you have the nth power on x plus y, then it's going to be the sum where you go down a row of Pascal's triangle. So that'll be n choose k, for k going from 0 up to n. And then x to the n minus k, y to the k, those are just the powers of x and y, where x starts out at the highest power and y starts out as just y to the 0. And then as you go down, x decreases gradually in power and y increases until you have y to the n at the end.